question box, and either Shalene, my colleague, or I will send them to you all after the webinar, so you can have a look and provide answers, hopefully, which we'll send along with the recording to all the registrants probably tomorrow or Friday at the latest. So just so you know.
Okay. Good afternoon, everybody. Good evening or good morning. This is David Coat from Thuis in Amsterdam. Welcome to the Translation Quality webinar. This afternoon we'll be talking a lot about quality in translation and QT21, which is a European Commission funded initiative to analyze and improve machine translation. For this afternoon, for this webinar, I've got 4 speakers. Christian Dugast, Lucia Specia, Kim Harris, and Marco Turki. We'll be talking for, well, 45-50 minutes, like that, something like that. After that, there is some room for questions and answers. We'll be talking immediately, giving answers immediately, and so you can type in your questions in the question box, and we'll always answer the questions. Maybe if it's not within the webinar, if time is running out, then we can also ask questions later on, answer the questions later on through email. I will take the opportunity shortly to announce upcoming webinars from Thuis, because in the following weeks will be some more webinars. Next week we'll have a webinar on datification in China. It's a webinar with speakers from UTH International and Team XML. Then we have a break of a few weeks, but in November 22 we come back with a webinar on the quantum leap, which is about deep learning, neural MT. You can find anything about that on the Thuis website. If you go to the events and then the events menu bar, you can find the webinars, and there you can read all about the upcoming webinars. If you have more interest after this webinar on translation quality, then you might also be interested in what Thuis does with the quality dashboard and DQF. You can browse on our website to see all the information about the quality dashboards and DQF and how you can get involved in that, and 't in the user groups. Just have a look. That's it for me. It's time to announce the first speaker. This is Christian Dugast. I will give him the floor right now for an introduction on our webinar for today. Christian, the microphone is for you. Are you there? Because
you're still on mute, Christian.
Okay.
I've put myself on mute. Sorry. So thank you very much. I was talking and talking.
All right. Yeah, I was incredibly silent. So, but have your way. Okay.
Okay. So thank you very much, David, for the introduction, and thank you very much for Thuis to giving us the possibility to show what we are doing at Q221. So my name is Christian Dugast. I'm just managing this project, and I would like to take the opportunity then to say a few words about Q221. It will not be long before we go into the into the matter of the webinar today, but I think it's good to know what we're doing and how far we've gone with machine translation. So now I'm trying to see. Yeah, okay. So Q221 is a project that has 13 partners. 10 partners are academic partners, and we have 3 industrial partners. Taos is one of them, Taxonform in Berlin, and we'll have Kim talking for Taxonform this afternoon, and Tilde in Latvian, who is also an industrial partner. So we cover quite a wide range of countries in Europe, and our goal is to improve automatic translation. And the name Q221 comes from, well, there are 24 languages in Europe, but there are 3 languages for which machine translation works pretty well, let's say, in terms of research. This is English, Spanish, and French. And so there are 21 left, and the 21 that are left are either morphologically rich, like German, Czech, and Latvian, or under-resourced, like Latvian or Romanian. So these are the 5 languages we've worked on. And with this project, we have also defined together with Taos then this quality assessment measure, MQM, now called also MQM-DQF if you want to use the part of developed by Taos. And we've worked also on learning from human feedback. It means that trying to take information from what human translators have given about what, or interpreting or correcting the output of a machine translation, trying to learn from it. And as always, you know if you make progress only if you measure yourself. This is very important in research. So we are working with an evaluation framework that has been developed by WMT. WMT stands for World Machine Translation. Actually, it's an old name. It was a workshop. For Workshop for Machine Translation. It was an old name. Now it's a conference. But it has been developed by the community in order to evaluate machine translation. And I'll say just a few words on this, just to give the idea of what it means. So it's about discussing results. So you have a community of researchers that work on machine translation that want to know and exchange information and experience on their work. So they take this workshop as an opportunity. We have a very well-defined framework. So we distribute training data and test data. So everybody has the same conditions to make their evaluations. We have also very well-defined evaluation protocols, so using BLEU, TER, but also human judgments. This is very important to be able to understand what's happening. And there are different shared tasks. And I would like just to present results of Q221 during the last 3 years on newspaper translation. And so it was WMT 15, 16, and 17. 17 in August this year. I will take just a subset of the languages, European languages essentially, that we've worked on at Q221. And this is English, Czech, and English, German in both directions. So this makes 4 language pairs. And each year we had a new or a different language pair. In 2015 it was English-French, 2016 English-Romanian, and 2017 English-Latvian. And when we do these newspaper translation evaluations of machine translation, we compare not only the systems of universities or research groups that present their own technology. In order to be sure that we do not forget anybody, we take also online and commercial systems. And online, it means essentially Bing or Google. They are also evaluated on these tasks. And just very quickly to show the improvements we've obtained the last years, I'd like to show what Q21 systems have provided or have reached in terms of results, and compare this with the best online system that we all know, like Google and Bing. In orange, you will have the number of systems presented by Q21, how they achieved this task, and here it's on with human judgments ranking. It means that you have human translator that evaluate the output of the system and try to see which one is the best one. And if you look at the first systems, the number of first systems for these 6 language pairs, you can see that in 2015 we had 4 Q221 systems and 3 online systems that were above belonging to the best systems. And 2016 we had a neural machine translation breakthrough, so neural networks have been introduced, and this changed completely the picture. And as you can see, we had Q21 won all the 6 the translation, the news translation task for the 6 language pairs, and only 1 online system could make it at the same level. 2017, it's a bit better for online system, but we are still very much far above. And if you look at the first and second ranking, then you see that still there was a difference in 2016 between Q21 and Q2 and online systems. They are coming back, but this is a good picture for us. If you look at the same test, but in BLEU score, BLEU score is automatic ranking or an automatic evaluation. You can see that within 1 BLEU score, and this is already, there's a significant difference between systems. So if 2 systems are above within 1 BLEU point, you can say they are more or less the same, but if they are within 2 BLEU points, then they are different. And as you can see here, there are only 1 best online system that is within 1 BLEU point of the best Q21 systems, or the best system anyway. And if you go within 2 BLEU points, you can see that well, online systems are still a bit there, but still far away from what we are doing. And if we go a little bit further and analyze what happened the last 12 months, here in orange, you have the Q221 systems. So the dark orange is the system from 2017, and in light orange you have the system from 2016, and in green you have the system from the online system from 2017. You can see that the online system have catch up between from 2016. They are better than we were in 2016, but they're still behind us on these 4 language pairs here. They are still behind us on when you look at the 2017 system. So actually, what does it mean? It means that actually data, and we all know that data is very important, that they fuel neural networks, that we are very dependent on data, but these online systems have much more data than we can have in our academic world, probably a few order of magnitude more data than we have, and they still cannot make it. So it means that technology is very important. Here are a few points that allow us to make the difference, but what you can take from this is that, well, we can be proud in Europe to have a very good technology that allows us to be at the top on machine translation. So this is what I wanted to say about Q21, not more. And this webinar will go further with, so have an introduction from Lucia about different MT evaluation paradigms, and then Kim will present you what can be done with MQM, and she will give some results and analyze the data that she has obtained. And last but not least, then we have Marco, who will show what can be done with human post-edits in order to improve machine translation.
Okay. Thank you so much, Christian. I'm going to switch over to Lucia. See if to hear her story. You can still ask questions, but we will keep them until the end. So if you have questions, you can ask them, but I'll keep them for later in the hour. But for now, it's time for Lucia. We can see your screen, so go ahead.
Hi everyone. Can you hear me okay?
Yeah, we can hear you pretty well.
Okay, good. So I'm Lucis Fessia. I'm a professor of language engineering at the University of Sheffield in the UK. And I'm mainly contributing to QT21 with automatic ways of evaluating translation quality and also estimating the quality of machine translation. So as I'm sure most of you are aware, there are many ways in which one can evaluate translation or the quality of a translation, depending on many variables. And we can keep this general. It could be machine translation, or it could be even human translation. And what I would like to do in this very brief presentation is to show you a sort of a taxonomy that I put together with all of these evaluation methodologies, which hopefully will serve as a bit of context for what is coming after my presentation, which will cover or the outcome of two main ways of doing evaluation and things that you can do with the data that's collected in those ways. So the first thing to clarify here is that I'm mostly interested in evaluating the final product of a translation system. So we basically see the actual system as a black box. So we have a given source text, it's translated somehow, we come up with a translation, and then we evaluate it, and we have this quality in quotation marks here, which basically can mean many things, as we'll see later on. But the system here is really treated as a black box. So it could be any machine translation system. We don't make any assumption about the type of system a priori. It could even be a human if you want to extrapolate translation to either machine or human translation here. So again, I'm sure you don't need to be told that, but there are many reasons why we would want to evaluate a translation, and I'm just listing some of them here. And you see that the reason is actually very important when deciding on the methodology that we want to follow for evaluation. So we could be interested in comparing MT systems or variants of the same system, or in optimizing models if you have statistical MT systems, or selecting different variants of the models if you have neural systems. We could also be interested in sort of understanding fitness for purpose, whether translation is good enough for something, or diagnosing a given system output to then maybe improve the actual system, informing end users, and so on. And this is a far from trivial task. There are many, like I said, variables that we need to consider in order to choose the more appropriate or the most appropriate methodology. We obviously need to know what we mean by quality. Do we mean a fluent translation, an adequate translation, or both? Or do we mean a translation that's easy to post-edit, that contain fewer or no errors of a certain type, such as terminology and so on? And again, there are many ways of defining quality. The decision also depends on what you're going to use the translation for. Is it going to be given to an end user? And if so, is it for gisting or dissemination purposes, or in other words, inbound versus outbound translation? Is it going to be given to a post editor, or is it going to be used by another application such as cross-lingual information retrieval, and so on? So many decisions, and there is no not a single formula, but these are things that need to be taken into account. So starting with the actual taxonomy that I've put together, the first major distinction that we have to make is whether we're talking about manual evaluation or automatic evaluation. And as much as I try and mimic manual evaluation with automatic metrics, if you know a little bit about automatic evaluation, you know that we're basically very far from that. So these are very different types of evaluation that we can do. So we'll start with the manual evaluation. So the sort of most straightforward way of thinking about that is to have a human looking at a translation output and giving it a score within a given range. And this range can, again, vary depending on how you categorize quality. I'm just showing here 2 examples of things that are traditionally done in machine translation evaluation. One of them is using a 4-point scale or 5-point scale in this case for adequacy versus fluency. So you're given a source, you may be given a reference or not, depending on how you want to frame the evaluation, and you're given the machine translation output, and a human has to say is in 1 to 5-point scale, how adequate is this translation and how fluent is this translation. Or you could have a binary decision to say, is this translation correct or not, which is a hard decision. And more recently, what has been done within WMT, this evaluation campaign that Christian mentioned, is we have a much wider scale between 0 and 100, and people are basically, or the evaluators are asked to pick somewhere in the scale in terms of correctness or fluency of the translation. This is what you might have heard of and referred to as direct assessment. Another way of doing human evaluation, which doesn't involve an absolute score, but rather sort of a comparison, is the ranking. And this used to be how we proceeded in WMT for many years. And in this case, we're not only given one translation at a time and asking for a score, but we're given a number of alternative translations. At most, it has been around 5. If we give more than that, the evaluators get a bit lost. But you give the output of 5 different translation systems or variants of the same system for a given source segment, and you ask humans to rank them from, in this case, 1 to 5, allowing for ties as well. And based on these rankings, then you can sort of estimate how good an individual system is, but only with respect to other systems. You don't have an absolute value for quality of segments or systems there. And finally, which actually not finally, but the next one is a lot more specific, as what we call error annotation. And in this case, you're not only interested in the general quality of the system, but you're interested in understanding what errors it makes and how frequently it makes those errors and so on. So we'll talk about that a lot in this presentation when Kim starts with the MQM data. But this is probably what you're most familiar with, where we have some sort of error taxonomy, and we ask a translator or an annotator to categorize words or sequences of words if they're incorrect according to the type of error. So moving a bit beyond explicit evaluation, still within manual evaluation, we have what I call task-based evaluation, where you ask humans to perform a task based on the output of the translation system. And then you evaluate that final task, and depending on how well that task, the performance of the task is, you kind of project that back to the MT output, and you can tell how good the quality of the MT output was. So the most obvious way of doing that is post-editing. So assuming that the task here is to produce perfect quality or fit for purpose or publishable quality translation output. So you give in raw empty output and you're asked to fix it when necessary and produce good quality output. And there are many tools to do that. Within the project, we use a simple tool that allows us to record a lot of data in the background, such as post-editing time and the edits that were performed, and so on. And we can use several metrics based on this data to evaluate the quality of the systems. For example, we can use a metric called human translation error rate, which basically measures the distance between the raw empty output and the final post-edited version. We could even look at time that was taken to post-edit the translation, and there are other things, keystrokes and things you could look at. And a little bit more distant from what most people are used to do, there's also things like reading comprehension tests, where one could give the empty output, say a translated news article, to a human and ask a number of questions on the content of the article, which could only be answered if the translation were correct. So by then assessing how good the answers to the questions are, one can assess how good the empty output was. This is a very expensive way of doing things, but for document or article level evaluation, it's one that is proved effective. So this is just an example. You have a full text, and then you ask either multiple choice questions or descriptive questions, and again, depending on how well a human do in responding to those questions based on the empty output, then you have a score for the translation. And now moving on to is even more abstract ways of doing this evaluation. The last task-based method that I would like to describe is one using methods such as eye tracking. You could even use things, equipment to record brain activity, but eye tracking is the one that people have used, which basically measures words. And well, basically you give the output of an MT system to a human who's asked to either only read it or to do something with it, such as post-edit it or do a task with it. And you have an eye tracker that measures how much time humans spent reading specific words and how much they moved from word to word and so on. And you can use this information to estimate which words were complex and how complex they were and so on. Okay, moving on to quickly now to automatic ways of doing evaluation. This is probably where you've heard most work about. So the first one is where you have reference translations, which are basically human translations that were collected beforehand, and then somehow you're comparing the output of an empty system to these reference translations. And there are very many metrics that allow you to do this comparison. The most familiar ones to most people would be BLEU or Meteor or TER, and there are, I can safely say, dozens and dozens of these metrics. Some of them were proposed within this project, the ones in blue and red here, and some are more linguistically motivated than BLEU. Others use machine learning to combine a number of other metrics, such as blend. And if you're interested in that, we can answer questions later on. But there are many of these metrics, and they all have follow a similar framework. So. And then finally, this is again a automatic way of doing evaluation, but where we do not have references. This is more targeted at systems that are in use. For example, if you want to inform your end user about how good a given translation produced by an online system is, you wouldn't obviously have pre-created references for that translation. That could be for a text that the user himself or herself entered. So in order to do that, we have another family of metrics that I call quality estimation, where you pre-train a model based on some annotation quality to be able to predict the quality for an unseen or for a new translation that you don't have a reference for. So we have, again, within the project, we have tools to do that. The main tool being Quest, quality estimation, and we've been testing it on our data, but we won't be able to cover that today. So again, this was just the final taxonomy, and what we'll do in the rest of the presentation is to focus on the error annotation and post-editing to some extent, error annotation with MQM, and post-editing more in the sense of once you've collected post-editing, what we can do with it to improve machine translation. And that's all from me. Okay,
thank you. I've got a question from one of the listeners. Direct access in your sheet that is on screen right now.
Yeah.
What does it stand for? He asks.
So this is direct assessment in the sense of having a translator or an annotator directly judging the quality of a translation. So it's not within another task.
No. Okay. Good.
Explicitly assessment.
All right. Yes, I see. Well, I hope that answers the question. I have to go quickly to Kim Harris, and I have to ask it to keep it a little bit short because otherwise we don't have any. Sorry.
Okay, I'll run through my screen. So can you see?
Yes, we can see your screen. It's clear.
Okay. So my name is Kim Harris. I am managing partner of TextInform, one of the industry partners in Qt21. Our job was to actually do the post-editing and annotation on the data. So data collection in Qt21, I'll just go through this really quickly. This is just to give you some background. We had between 20 and 45,000 sentences of industry-generated content in IT and life sciences, and a subset of almost perfect sentences with MQM error annotations. The type of data that we used is significant, and I do need to mention this because contrary to what the work that's done in WMT, which is news data, we wanted in this project to use industry data because most of the data that is actually needed in several languages is industry data, and we wanted to see whether or not we could find distinctive patterns in some of the errors that were occurring in this data. This is very useful for industry because a lot of companies have a large volume of data that needs to be translated, and if we can detect patterns in some of the material coming out of the MT systems, that would be very useful. The problem is, of course, that it's very difficult to get your hands on industry data simply because most corporations are not allowed to provide their data for this purpose. We used, for this project, professional bilingual translators with post-editing experience. This makes us quite a bit different from a lot of other projects that use crowdsourcing or monolingual people for their evaluations. This will become significant later when I talk about the NMT output because of the fluency issues that occur in SMT but do not occur in NMT. We trained all of our resources. We have a wiki with guidelines. This is always work in progress. We are constantly updating the guidelines to reflect some of the issues that we've come across during the work that we've done. So Lucia talked a little bit about the post-editing process in the sense that we gathered a lot of data during post-editing. So we collected editing time, keystrokes, the actual edits, meaning whether words were added or deleted, which keys were used, and so on. And the translators were asked to provide a score based on predefined criteria, which was perfect or near perfect, very good, poor and very poor. So the annotation process, what we did with the annotation, the purpose of the annotation process was to see whether or not we could find patterns in specific error categories in the MT output, both of the SMT system and the NMT system. It was really an interesting experiment to actually gather information on actual errors. Instead of just using, as Lucia had said, automatic scoring, we decided that we wanted to go a little deeper into the actual errors that were occurring to see whether or not there was anything that could be used to actually improve the output. So we did, after post-editing, we asked our translators to annotate 2,000 sentences per language pair and system. These were ranked, these sentences that we annotated were ranked as good, and they were randomly selected. We decided not to annotate sentences that had a lot of errors, and this was because a translation can be, you know, 10 translators can translate one sentence in 10 different ways. And once you are dealing with too many errors in one sentence, first of all, you're prone to more errors, and second of all, you move much further away from the original MT output than we actually wanted to do in this project. We did some double annotation on 200 sentences just to check inter-annotator agreement and to see where there were divergences in order to either improve our guidelines or to be able to look at how these errors were categorized and what needed to be changed. The tools and methods that we used, so we used PET. Lucia had shown a screenshot of the PET environment. This tool was the one that allowed us to do all of the logging of keystrokes and time and the types of keys that were actually used. Translate 5 is a translation environment that integrates MQM and allowed us to do the annotation. Originally, we had wanted to do everything in one workflow, but unfortunately, we had to use 2 different tools for this because Translate 5 could not incorporate all of the data points that we wanted to have, such as key logging and time logging. And of course, we have the multi-dimensional quality metrics MQM. This is a now very widely used annotation based error categorization, and it has become standard. There is a harmonized DQF MQM version that was also developed as part of the QT21 project. So as part of the annotation, when we first did this in the previous project, QT Launchpad, we discovered that people were having difficulty determining or deciding which error to actually choose. So during that project, we developed this decision tree that allows you to determine, first of all, accuracy or fluency, and then from there, omission, terminology, whether it's grammar, part of speech. And we found this to be very useful. Our translators also found it to be extremely useful. Once you get used to it, you don't need it anymore, but this was, you know, there was something that was a little tricky in some of the error annotation, they could always refer back to this graph. So I just want to now focus on some of the findings and results. I have to say, first of all, that we are really only at the very beginning of understanding and looking at some of the results that that we have come up with. It's very difficult to take 45,000 sentences and put them somewhere where you can actually flexibly look at different parts of the results. So we are working on doing that at the moment, and these are just some of the things that we have noticed ourselves or have come across by interviewing some of the people who have done who did the post-editing and annotation. So as you can see, obviously, for all of the languages, the average PE time for SMT was much higher than NMT. Well, for English German it was. This was what we expected, but what we didn't expect was that it wouldn't, that the amount of difference between the two is actually much lower than we had anticipated, both in terms of the average PE time and in terms of the average keystrokes. Interesting was for Latvian the fact that SMT was much more efficient than NMT. It's not that this isn't to be expected, especially because tilde does focus largely on SMT Latvian, but these languages that are morphologically rich are also very complex and difficult for even neural systems if they aren't trained properly. This is a very interesting table because it gives you the number of errors in the annotated material, so the 2,000 sentences that were annotated to date. We will be doing more of this as well because the results were so interesting. As you can see, that function words were the largest category by far. And agreement and word order were the major categories for SMT, which is not unusual either. What we found very interesting was if you look at the number of mistranslations for both SMT and NMT, NMT has 852 singular errors, but if you look at the number of errors in total, it's 3,700. So it's almost twice the number of mistranslations that were categorized for NMT as were for SMT. And this is important because this is part of the reason why we believe there is less of a difference between the effort required for both systems. So the information that was collected during post-editing, we think can be used in various combinations in order to determine different things. So you can you can determine the actual post-editing effort by translators based on time and keystrokes, but you can also compare these to the perceived level of quality of the post-edited sentence. For example, we had quite a few NMT sentences that were very fluent, had errors, were categorized as having better quality than an SMT sentence with less errors. So here you're looking at fluency as being perceived as better, even though the number of errors in the sentence was higher in NMT. And also being able to establish certain relationships between various sentence characteristics like length and post-edit time. We found that NMT sentences that were longer took longer to post-edit than SMT sentences, and this also, I think, we believe is related to the types of errors that occur in both systems because they're both very different. This is also something that was developed in the previous project. We call it our pretty print. It allows us to visually compare the sentences and the annotations, so the various annotations that were completed for a particular sentence. So you have your source, then you have your MT output, you have your post-edited output by annotator 1 and post-edited output by annotator 2. And you can combine those and compare both systems as we've done here, but it can also be put into one screen. So this is something that we observed and found very interesting based on just some preliminary results that we found. While SMT has significant fluency issues, it leaves unknown words untranslated, and it systematically omits specific sentence structures. So it's, for a post-editor, it's much easier to recognize error patterns. NMT, for example, has excellent fluency results, but it translates words incorrectly and it omits random words. So if you had, for example, someone post-editing without having the source, or trying to establish the quality without having the source, you might have issues because the fluency of an NMT sentence will be excellent compared to an SMT sentence. contrary to that, the perception of the SMT sentence, because it isn't quite as fluent, is pessimistic. So the quality scores that we were getting for SMT were lower than the quality scores for NMT, even if the NMT was actually not as good. The predictability of the errors reduces the cognitive effort required by the post editor, meaning once you get into the rhythm of doing your post edits, you automatically look for certain patterns in the sentences that allows you to find these errors much more quickly. This is not the case for NMT, we found, and we found that the cognitive effort that was required for the NMT output, in particular for the very long sentences, but not only for the very long sentences, was actually higher than it was for the SMT sentences. So the amount of time, as we saw in my previous slide, the amount of time required to actually post-edit even a perfect or near-perfect sentence in SMT was not as low as we had anticipated compared to the SMT output, which was very, very interesting. Just a couple of examples. I'll just try and go through these very, very quickly. For example, the NMT left out dim in this sentence, which is a significant word to leave out. SMT used an incorrect word, but it used a word that would actually at least convey the meaning of the sentence. So if you don't have the dim check mark and you only have a check mark, then it's actually the opposite. The NMT left out partitions in the second example, just randomly for whatever reason. And in the second sentence, the SMT, it was agreement due to distance, and this is a very common error in SMT machine translation. This as well, so the NMT just left out the sort from table. It didn't know what to do with the word sort. SMT translated it incorrectly, with an incorrect part of speech, but it's much easier for a translator to fix this than to actually have to go back and look at the source again to see what's missing, if there is anything missing from the NMT, because it makes sense in this context. So again, typical NMT errors are random omissions, random mistranslations while maintaining fluency, and this makes it very difficult for a post editor to actually post edit quickly. One of the things that we would like to analyze, which we have just simply have not had time to do, is to look at whether or not certain errors were missed in the NMT. Potential data uses. So we think that this data that we have collected can be used both by research and industry in various scenarios, especially looking at cognitive effort and perceived effort by the translators, and looking at whether or not there's a difference, and comparing the amount of time required. This means that some of the guidelines or some of the work that you need to be doing with your post editors will be much different than the work that you did using an SMT system. Another thing that we think, another use we think would be very good for this is for you to be able to, for industry or research as well, to be able to benchmark their automatic scoring systems against the quality scores and all of the data points that we collected here, as well as the BLEU scores that we have also collected. So you can look at some of your own, if you have your, and even if you have your own metrics, you can actually use this data to benchmark against.
Kim, I think we need to go on actually, because otherwise we run out of time. I'll have Marco, who also needs to have a few minutes to present his work. So it's very interesting, but if you don't mind, I give the floor to Marco.
Yes.
Okay. But thank you very much so far.
What's up? What's up, Ben? Wait, give me a second. Something is not working here. Okay. So can I go?
Yes, go ahead.
So good afternoon, everyone. My name is Marco Turchi. I'm a researcher at Fondazione Bruno Kessler in Trento. And in the last part of our today presentation, I will talk about automatic post-editing. I will be quick, so don't worry about the time. So as we have seen from the previous presentation, in particular presentation by Kim, empty systems produce errors. So our goal is to try to improve the translation quality solving this error. For doing that, we need to have some requirement. First of all, we need to have access to the empty system that we want to improve, but this is not always the case, because if I use Google Translate, I cannot open it and try to improve it and to try to fix the errors. Another requirement is given by the fact that particularly if you have a small companies, LSP, you need to have the time and the right knowledge to open the empty box and try to improve it. Ideally, what we would like to have is an external tool that can fix the error independently from the machine translation system, can use a smaller quantity of data compared to the empty system. So instead of using millions of parallel sentences, it can use just few K, and it should be also use quick deployment of the system. In particular, if you receive a project that should be released, should be finalized in a few days, you cannot wait for weeks before you train your system. So automatic post-editing system try to satisfy some of these constraints. So in the rest of the presentation, I will show how we can leverage the human post-edit data that has been presented by Kim to improve translation quality. The goal of the automatic post-editing is to take a sentence that's been translated by an unknown empty system and to improve it, trying to fixing the error that are present in this target sentence. The idea is that we need to have some triplet, so source, the output of an empty system, the human post-edit, that I can use to train my system. When the system is ready, it's receive the source and the empty output and try to produce a better sentence. This kind of technology is well suited in the CAT environment, where there is a professional translator that, given a source and a suggestion, produce a human post-edit. The human post-edit is passed through the AP component that improve over time. And when it receives a source and empty, it produces a better translation that is passed back to the professional translator. So we can create an integration between the professional translator and AP component that try to both of that to help each other to improve the quality of the final output. So what are the ingredients to build an AP system? We need some data, and as previously said, the data consists in the source, the output of an empty system, and the human post-edit. And we need much less data compared to the empty system. So we are talking about 23,000, 24,000 triplets. I would like to highlight that this data for a company is easy to access to them, because most of the company have this data. But in the research community, these data are not available. And for the first time, Qt21 made available large quantity of this data to the research community. One important aspect to say is that the data that we use to work are domain-specific data. If you think about what does it mean to be domain-specific, it means that you have very coherent sentence that talk about the same topic. So it means that you can find recurrent error that has been fixed by the human. So this, of course, is easier to be learned by machine. There are several methods. You can see the first paper was in 2007, where I used the classic phrase-based approach to produce automatic post-edit. But last year, neural AP showed to be the prominent technology, and this set the new state of the art. That has been again a move created this year with the 2017 AP shared task at WNT. I will talk about this later. So now let's see. So what is the key question we want to answer? Is automatic post-editing useful? Does it work? So we organize inside Qt21 the automatic post-edit shared task at WNT, where we provide some trained data, in this case 23,000 information technology English-German triplet, and then we provide the test set, which consists in source and empty sentences without showing the participant the human post-edit. And then we ask the participant to produce a better output of this test set. We are at the third edition, and this year we reach incredible results compared to the previous years. So as you can see here, these are the blue bars represent the participant. The participant can submit several system. Here we consider only what we call the primary summation. So what the participants identify as their best summation. On the y-axis, we have the BLEU score, as Lucy and Christian talked about it, is an automatic matrix that compare the output of the AP system against the human posterity. And we have two baselines. One is the do-nothing baseline, which is the empty output, plus we have the phrase-based system, which is trained on the data that we release. As you can see here, for the first time in the automatic posterity shared task, we saw that all the systems which are neural, the blue bar are neural AP system, are able to beat the baseline and also the phrase-based, showing that neural is much better technology for this task. But what really shock us is the improvement that you get compared to the do-nothing baseline. As you can see, the improvement is around 7.5 BLEU score. So it means that you can, with just a few thousand of posterity data, improve the BLEU score by something which is incredibly large. And what is also interesting for us is that the phrase-based system can beat the do-nothing baseline, but it's very far from the neural AP. So looking at these results, this confirms that the neural is a new technology, that we set the new state of the art in automatic posterity. And yes, automatic posterity can really help to improve translation quality and is effective. But these results are based on BLEU score. And as we know, BLEU score is not quite good metric, it has several drawbacks. So we ask human to evaluate the output of all the participants with two goals. The first one is to see if the ranking produced by the BLEU score is reliable. So also the human has the same perception of quality that is measured with the BLEU score. And the second one is the differences between the system. So if there is a difference of 0.5 BLEU score is perceived by human. So for doing that, we use the direct assessment technology previously introduced by Lucia. So it means that giving an AP system and a reference, we ask them to rate, to give 100 if it's a perfect output, or 0 is a very bad output. We use crowdsourced student. Going into German is not easy to find a professional, let me say crowdsourced translators for this language. And then we compare all the AP system, and then we add also the human posterity and the original empty output. In this plot, you can see that you have in the green bar, you have the human, then you have in the red nothing, then you have in the middle all the system. On the y-axis, you have the average score in terms of direct assessment assigned by the annotators to the sentence for that particular system. So 85 means that it's very good because it's close to 100, and the red bar is much lower than it. So we can use some statistical tool. We cluster together the system that are not for the human. So human is not able to identify if one sentence comes from AMU, FBK, and DCU. So the quality of the system is very close. So as you can see here, there are 3 different clusters. But again, so first of all the AP systems are better according to this human evaluation than the do-nothing baseline. Unfortunately, they are still far from the human posterity, so it means there is a lot of work to do. And this is more or less what we would like to see. And also in terms of ranking, there is not a big difference between the BLEU score and the human rank. Yes, it's true that FBK initially was the first system, now is the second, but AMU and FBK and DCU are in the same cluster, so the system for the human are more or less the same. So I think it's over on my side. I hope that I was on time. Yes.
Yes. Okay. Thank you, Marco. Yes. Well, let's wrap things up, and it's almost 6. It's almost over. But I will go shortly back to Christian to wrap it up. This webinar. And then probably don't have time for the questions anymore. But go ahead, Christian.
Yes, it's just a very short summary. It's about telling that. Oh, yeah. So what you saw is you got an overview of different evaluation paradigms for MT, and what you could see also is an analysis of the differences between SMT systems and NMT, where NMT actually produce less predictable errors than SMT, and the post-editing productivity may not really profit from NMT, but this is probably also a question. Is it just a question because it's too near to SMT or too new? This is still open, but this is what we could analyze from the data we got. And what is very interesting is actually that human post-editing can really profit to MT, and that we can improve a posteriori then machine translation with taking the knowledge we can get from post-edits, and this rather dramatically. So thank you very much for your time, and I hope we could give you some interesting information. And I'm pretty sure that David will be able to receive questions, and we will be delighted to answer these questions when we get them.
Yes, thank you very much, Christian. Yeah, I got quite a few questions, but time is up, unfortunately. But thank you very much for the very interesting research and webinar. I got a lot of remarks that from the people that they found very interesting. So that's good to know. I will let me see if there's something else. No, I can. I will have to close the meeting. So again, thank you very much, and we'll get back to the questions, but that will be with email. So thank you all. Thank you for listening, and well, maybe for next time. See you again. Thank you all. Bye.